Hello everyone, and welcome back to another geostats tutorial video. And in this video, I want to walk through inverse distance weighting using the gstat package and the SP package. So the first thing that we're going to want to do before we do anything else is generate our data set. So in this case, I'm going to be using the Fulmer data set from our previous example. So I'm just copying and pasting that code so that we have a fresh, clean version of the data set. So just really quickly, again, x and y are the coordinates, and this Fulmer is the variable that we're interested in. We're just going to quickly create that into a SP data structure. So what we're going to run first, before we do any actual IDW, is generate some points where we actually want to calculate or estimate. Right? These are going to be our unknown locations. And luckily for us, the SP package has a useful function called SP sample. So you can see it takes in x, an n, and a type. So x is going to be the boundary of the current data set. So if we just pass in our this is our existing data. This just basically says don't go outside of this data. So this is like the bounds of where we want to sample from. N is the number of sample points. So let's go ahead and do 1,000. So we're going to have 1,000 randomly displaced points that we're going to call our unknowns for IDW to sample. Finally, we need a type. Type can have any number. There's a number of different parameters. The two that you're going to want to be most worried about are what are random, which is going to make a random, and then there's a regular, which would make a grid. But we actually want to go ahead and use random. So if we run that, just really quickly to show you that it ran, if we just quickly plot sample, you'll see that we now have a bunch of random points distributed throughout our study area. So that's all this did. This just generated unknown points to interpolate. All right, that's all this did. Now let's get into the actual IDW. IDW is actually very simple. We're going to call the gstat package, and there's a function called IDW. So you'll see that IDW takes in. Actually, let's go down here so we can actually see all the parameters. Question mark IDW. Okay, so it takes in as parameters formula, location, and new data. These are the three that we need to worry about for IDW. And then if we scroll down somewhere down here, IDP. This is the fourth thing that we need to worry about. So let's go ahead and put those in here. We need to have our formula, our locations, we need our new data, and then we need our IDP. So formula is basically what variable do we want to actually interpolate. And the way that we specify that is not in quotes, the name of the data, variable. So remember, if we just quickly type, go back to our head here, right? The name of the column that we want to interpolate is called Fulmer. And I just want to make sure this is clear because we've sort of got several different Fulmers lying around here. The name of the column is Fulmer, right? So we're going to use Fulmer, and then we're going to use this tilde, and then the number 1. So this is saying interpolate based on Fulmer. Okay, so hopefully this makes sense. This is probably the most confusing part of gstat and IDW is this formula here. So this is saying grab a column from the data frame and interpolate based on that. Locations. So this is the data set that we are pulling the data from. So in this case, it's f_spdf. Right? And the reason we're using locations is because this has both the data and the locations as well. New data, these are the sampling sites that we want to interpolate at. So in this case, we're going to call samp. So this is our unknown points that we set up before. Now IDP, this is the IDW specific parameter, and this is that alpha, right? If you remember back to the conceptual setup of IDW, that distance, inverse distance, is weighted by this alpha parameter that basically says, well, how important are we going to make distance? So by default, we're going to make that a 1. In some activities, you're going to mess around with this, but for now, we're just going to run it at a value of 1. So if we run that, it should run pretty quickly. And then what I want to do is I want to actually look at the IDW. So IDW in this case is a spatial points data frame. So it actually gave us back a geometry. And if we do IDW at, you'll see that we get data. And then we have the chords. We have all the stuff we're used to seeing. I want to look at the data just really quickly. I want to wrap this up in a head so that we don't print out an ungodly number of rows. So we're just going to print the first 6 rows of the data frame. So what you'll see here is that it's converted this formula here with Fulmar. It's now called it var1.pred. So this right here, this is the interpolated value at the points. So this is what you're going to want to plot. So what we can do here is we can do something like this. We can call it tmap equals tm shape. We can pass in our IDW because again, this is a geometry that it returned to us. And we can call tm dots. And we can call the color based on, in this case, this is where it gets a little confusing because we've now changed the variable name to var1.pred. Right, and if we call that, we don't get any crashes. And then if we do tmap and run that, you'll see that we now actually get our predictions here. So hopefully that makes sense. If any of this was confusing, I strongly encourage you to reach out. Thank you.